So good evening to one and all.
Good evening, sir.
Okay. Okay, right. Now we will start with the new concept, that is the water resources. So previous week we solved some problems. So any doubts we will discuss in the last part of this class. So freshly we will start this new concept, because 3 to 4 questions you can expect from this concept. Maximum 3, but not more than 4. It is maximum 3 we can expect from this topic. So what are the present water scenario, water resources available in India? What is the major water resource for irrigation or drinking purpose, or which is the main important source for now the drip irrigation or triple irrigation or something like that. So now we will discuss some part of that. Okay, what is the water resources available that is in agriculture? Here you can see water usage in different sectors. You have to concentrate only on India. This you have to market. That is agriculture 82%, industry 12%, domestic use 6%. Maximum they will ask for agriculture purpose. Total water usage in different sectors in India, it is 82%, and you can also concentrate the world. Here the world also total it is 69%, but which is the nation which is using maximum for agriculture is Africa. This is the first point you have to note down. Totally 3 questions here itself. You can expect 3 questions. In our India, how much percentage of agriculture, how much percentage of water usage in agriculture is 82%. In among the world, which is the first nation, the nation which stands first for usage of agriculture, for usage of water in agriculture scenario, in agriculture sector is Africa, that is 88%. When compared, when come to the world scenario, it is 69%. This is not required. Only thing is our India, and which is the first nation. So the second point here, please note down this point: 82% in India, and Africa, the first nation, 88%. Okay. Here you can see water plays a key role in photosynthesis of plants, in which chemical energy is converted into biological energy. What they will give the definition of photosynthesis. It is the conversion of chemical inputs, for example, not chemical inputs, so complete environmental inputs. It may be solar energy or water or wind or soil nutrients. They are all environmental inputs into outputs, whatever the required for human purpose. That is, output is in the form of food for humans, feed for animals, or something which is the energy source for all other organisms. That is nothing but photosynthesis. That thing you may expect in the question. That means, what is the definition? They may give the definition: the process of conversion of environmental inputs. The definition is not here. I'm saying the process of conversion of environmental inputs into human output, human required outputs or animal required outputs is nothing but photosynthesis process, where the water plays an important role. Okay, for the photosynthesis process, for the release of oxygen, the water is required. Okay. When it comes to the world water resources, about 70% of the earth's surface is covered by water in solid, liquid, and gaseous forms. It will be represented in next table. The total water available on earth's surface is 13,84,120,000 kilometer cube, but it is not required. You should not mention here. Only thing what you have to remember is here this table. That is water resources in the world and also water resources in India. Here, overall, the earth atmosphere, the presence in the volume is 13,000 kilometer cube. This is the one you have to remember the point. The earth atmosphere contains the water 13%, that is 13,000 km cube, that is kilometer cube. They will not ask any oceans or polar ice caps or nothing like this. Only the earth atmosphere is important, that is 13,000 kilometer per cube. So the second important point here is classification of the earth cultivated area. What you can expect, all the 6 are very important. You should not never forget all these 6 points. That is arid, semi-arid, subhumid, humid, wet, and very wet. This is the earth's cultivated area classification. You may be confused with this classification, because when it comes to this climatological data, Thorndthwaite has divided this arid, semi-arid, subhumid, humid, wet, and very wet conditions. In also in Earth's cultivated area, arid, semi-arid, subhumid, humid, wet, and very wet. These are all the classifications. So You should not confuse with these classifications with the Earth's cultivated area and also with the classification of the torrent weight. The annual rainfall in arid climate is less than 250 mm. When it comes to this percent cultivated area is 25%. Here you can expect one question, that is, which is the cultivated area in the earth which is having highest percentages of cultivated area. Here you can note down that semi-arid area is the region where we can expect more cultivated area, that is 30% of the cultivated area will falls under semi-arid region, that is 250 to 500 mm of the rainfall is the important one. So next is subhumid region, that is 500 to 1000. The percent cultivated area is only 20%. You should not remember this. Only the thing is the percent cultivated area is highest in case of semi-arid region, which receives the annual rainfall of 250 to 500 mm. So another one question you can expect here is very wet condition. Now the scenario is very different. That is very wet. The very wet condition, that is what is the annual rainfall required for very wet condition is more than 2000 mm, but the cultivated area is only 5%. Where this percent is coming is very wet, where they are using very wet condition is in case of Himalayan region. That Himalayan region falls under wet region, but in case of very wet condition, where you can observe that some boats are flying boats are there in case of Kashmir, and also in case of some parts in the Kashmir, where you can have floating boats are there. There, that very wet condition, they are cultivating the agriculture, that lies under percent cultivated area is 5%. In this entire table, what you want to concentrate is the percent cultivated area. The maximum percent cultivated area is lies under which region? Arid, semi-arid, subhumid or humid? Answer is semi-arid region, that is 30% of the cultivated area. Okay, and the amount of annual rainfall in that area is 250 to 500. This much is enough for you for the remember for the JRF questions. In case if you are preparing for net, you have to remember everything, because in that region they will ask humid or subhumid or anything you can expect, but in case of JRF only the highest values or lowest values or the maximum values they will ask. So you have to concentrate on this semi-arid region. Okay, when it comes to the water resources of India, you can expect what is here. Also one table is there. That table you have to this is a pictorial diagram of the India, where you can see the amount of water present in that India. This is not required, only the thing here comes. Okay, the important table you can expect questions is inland water resources of India. Here you can see rivers and canals, the length. Earlier they are asking the questions, what is the percent salt water present, what is the percent of snow, or that is you can see that 97% of the salt water, among 2% some other water is there in ice caps, then infiltrated water, some other questions are earlier they are asking, but now they are concentrating on length. What is the river's length and canal's total length? That is 1,95,000. In roughly they will give the option of 2 lakh kilometers. This you have to concentrate, and please note down this point. Rivers and canals, that is the length in kilometer. What is the total length for the rivers and canals in India is 1,95,000. It is the very important question you can expect. And other water bodies, here now comes the million hectare, that is reservoirs. What are the complete reservoirs? That may be any reservoir, that in case of present in case of Andhra Pradesh or in Tamil Nadu or Karnataka or Madhya Pradesh, Uttar Pradesh, anywhere. But the total million hectare covered by the reservoirs is 2.93 million hectares. This is the question you can expect. You should remember all these four, that is reservoirs, tanks and ponds, floodplain lakes and brackish water. The brackish water, still now they have not asked in any SRF questions or in net, but this reservoirs and tanks and ponds, reservoirs they asked in SRF question, and tanks and ponds they have asked in ASRB prelims. So you can expect this question, what is the million hectares covered by reservoirs? That is a 2.93, and tanks and ponds 2.43 million hectares. Okay, then floodplain lakes and direct water bodies, that is 0.80, brackish water is 1.15 million hectares, totally 7.31. It is not at all required, only the reservoirs, tanks and ponds are required. So after that, what is the storage capacity? That different it is there. Here you can see river basins in India. For the preparation of SRF or net, you should remember the major river basins in India. Okay, the first one is Ganga, Brahmaputra. Here Indus, it is up to border. Still now they have not asked the questions again on this. Only the question asked is Ganga. On the Ganga they have asked what is the catchment area and utilizable surface water resources. Highest it is Ganga only, that is 250 billion cubic meter. Here you should remember which is the water river basin which is having highest utilizable surface water resources. Surface water resources is Ganga, that is 250. Compared to all other river basins, Ganga stands first for the utilizable surface water resources. This question you can expect. You should not require to remember all these units. They are not at all required. Only the utilizable surface water resources is highest in case of Ganga is required. But when it comes to the southern part of India, which is the one having highest utilizable surface water resources, that is Godavari. In question, please look after whether they have asked South India or the Northern India, because when it comes to the Southern India, this Godavari stands first, that is 76 BCM of utilizable surface water resources. So if you see the question paper, the chances of giving the option both Ganga and Godavari. But what they have concentrated, they have concentrated southern India or entire India. Only the southern part of the India, if they have mentioned, means you have to go for the option Godavari, because in some multiple choice books or in some competitive books, they some books they are giving Ganga and some books they are giving Godavari, because if the author is southern part of the India, then he will give Godavari. If he is from northern India, he will give Ganga. But the answer is whether the question is concentrating on southern India or whole India. When it comes to the whole India, that is Ganga. When it comes to the southern India, that is Godavari. Okay. Then Brahmaputra, here average water resources potential. Here it is not at all required. It is required for only SRF or net preparations. But when it comes to the JRF preparations, utilizable surface water resources, that is Ganga and Godavari. But when comes to your entrance papers, if you are writing JR after, if in your state some entrance papers will be there, so they will ask their own states. For example, if they are in Karnataka, they may ask about Krishna and Kaveri. And if they are from Penna, if they are from Tamil Nadu, they may ask about Pennar and Mahanadi. And some other states are having their own water resources. So they may concentrate on the resources, water resources available in their own states. So what you have to observe is when preparation for JRF, you have to concentrate on entire whole India or something parts. But when the preparation for your state entrance, you have to concentrate on your state also. Then in that paper they will not ask whole India or southern India, they will particularly ask on your states only, which is the major river basin in some Gujarat or some in Maharashtra or some in Madhya Pradesh. That questions you can expect. Okay, then now the total ultimate irrigation potential in the country stands at, this is the one question which you can expect here, that is the total ultimate irrigation potential of the India is 140 million hectares. In some competitive books, they have mentioned 145 million hectare. That is 145 million hectare in some books and 130 million hectares in some books. 130 million hectare is the data of 2010. You should not confuse with whether the 130 or 130 is correct or 140 is correct. That is 140 is the present 2019 and 20th data. You have to concentrate on the present data. Don't go for with the old data. When you are reading some data in the textbooks or in the competitive books, please refer when it is published, because that data may alter. Not all the data, some particular data will vary. So 130 million hectare is up to 2010, it is correct, but now it is 140 million hectare. And in some competitive books, mismatchingly they have given 145 million hectare. It is also wrong. The total ultimate irrigation potential in India is exactly 140 million hectare is the correct answer. So don't confuse with that competitive books. Okay, then the share of minor irrigation is 22.96 million hectare. That it is not required. Okay, then what is the surface water flow, evapotranspiration? Already we discussed. River systems in Karnataka, that is not required for you. So this is the water resources present in India. And some questions you can expect from the water resources are tank well irrigation, bore well irrigation. I will give you the research data in the last classes, because the data what they published in ISA or uh, in some units, they will give at April month, because whenever if the examination during you will have the JRF examination on May month, some data that is a total grain production or total cereal production in that year, and also this irrigation related recent data will be published in April month. So I will provide the data in April only. It will be useful for you also for remembering that concept. Okay, then when comes to the next concept, that is this is the previous concept what we have learned in that lecture 2. This is also over. Regarding these problems is also over. So finally, now transpiration and energy. Okay, what is the transpiration and whether it is a transpiration is a necessary evil? Transpiration is necessary evil. Why transpiration is necessary for the plants, we will discuss now. First of all, what do you mean by transpiration? It is the amount of the excess of water is lost from the aerial parts of the plants in the form of water vapor. This is called transpiration. Why plants require transpiration? Because excess water must be moved out from the water plant surface. What happens when the transpiration occurs? It will create cooler climate for the plants. That point you have to note down. Here it is not there in the notes, but you should remember this point. After transpiration, why the plant surface will be in cooler climate. Hence, if you stands below the plant surface, that trees, if they are in they will give some cooler climate. This is because the entire microclimate of that plant or a tree species, after the transpiration, the plant will be in cooler conditions. That is the point what you have to remember. Please note down that point. That is a transpiration. After transpiration, the plant surface will becomes cool. Okay. Plants need such process of absorption to be lost water. They need mineral cap. Why we required means for mineral transformation to keep cooler even at higher temperature. This is the one highlighted point, to keep cooler even at high temperatures, necessary to transport photosynthesis. This is all which is in present in the textbooks, but the only point is to keep cooler even at higher temperature is the one point why the plants require transpiration. Okay, all enzymatic reactions are readed, keep the trajectory of the plant. These are the points. Okay, then totally three types of transpiration is there: stomatal transpiration, cuticular transpiration, and then lenticular transpiration. Okay, what do you mean by stomatal? Here you should not remember all those things. Only the thing is maximum transpiration occurs through stomata. That is 90% of the transpiration occurs through stomatal transpiration. Only 10% is from cuticular, that is from cuticular transpiration. Okay. Here what you have to understand is lenticular transpiration occurs in woody stems through lenticels. This you have to note down. That is woody stems through lenticels. Stomatal transpiration is 90%, followed by cuticular transpiration 10%. Then what are the mechanisms of stomatal transpiration? Here, osmotic diffusion of water in the leaf from xylem to intercellular space above stomata through the mesophyll. Here what you want to understand is why the stomatal transpiration occurs. That is osmotic diffusion. When the concentrations in the guard cells which increases, then the guard cells become open, then the stomata will also become open. This is the one which is present in osmotic diffusion. And then the second point is the second point is potassium concentration. During morning, because of increase in the potassium concentration, then the guard cells will open, stomata will also open. And in the morning condition, in some crops, starch synthesis will take place. Because of starch hydrolysis will take place. Because of that process, because of increase in the sugar concentration, sorry, that starch concentration, the guard cells will become open. Because of the opening of the guard cells, the stomata will open. So these are the three mechanisms. If you see this entire thing, it will be clumsy for you. So I will say in clearly, totally three concepts are there: starch synthesis, stomata will open; potassium concentration, stomata will open; osmotic diffusion, potassium, this guard cells will open. So these are the 3 to 4 mechanisms are there for the stomatal opening. Okay. What are the mechanisms of control of stomata? Here what I explained is hydrolysis of starch into sugars in gases, synthesis of sugars or organic acids in them, and the active pumping of K plus ions in the gases. These are the mechanisms why we concentrate on stomatal transpiration. Okay. Simple diffusion of water vapor from interstellar spaces to other atmosphere. That is, this is not required for you. These are the different factors where some concepts of yeah, transpirations are yeah, needed. Okay. Energy for water loss. Here, what you want to concentrate is VPD, that is vapor pressure deficit. I will explain what is that. Presently, the enthalpy of vaporization, also known as latent heat of vaporization or heat of vaporization. This is the definition you have to mug up or you have to understand very clearly. It is the enthalpy change required to transform a given quantity of a substance from a liquid into gas at a given pressure. That is the latent heat of vaporization or heat of evaporation. In options you can expect they will give the definition, which is the phenomenon of enthalpy change required to transfer a given quantity of substance from a liquid into a gas at a given pressure is known as enthalpy of vaporization, latent heat of vaporization, heat of evaporation, all the above. The option must be all the above because in some books they may give only this point, latent heat of vaporization. They will not give heat of evaporation. When you read that only one book, you may get confused whether we have to choose latent heat of vaporization or heat of evaporation. So in that situations you have to observe this point because all the three are same. Enthalpy of vaporization is same, latent heat of vaporization and heat of evaporation, not heat of vaporization. Here you have to concentrate. In the case if the choice is heat of vaporization, don't mark that option because evaporation and vaporization are clearly, they are clearly different and you should not say choice the heat of vaporization. Answer must be heat of evaporation. That is the enthalpy change required to transform a given quantity of substance from a liquid into a gas. Liquid into a gas. That is the definition what you have to understood. Okay. Then in order to close the stomata, what are the transparency required? Here you can, in all the textbooks they have given the stomata closing type, reflectant type, filiforming type and growth retardant. Okay, what is the new thing you have to identify here is, you can expect earlier questions they will give example like phenyl mercuric acetate PMA lies under stomatal closing type or reflectant type or filiforming type or growth retardant type. Earlier questions you can expect, that is PMA will lies under stomata or some other. But now what you have to observe is, here they cause a partial or complete closure of stomata by inducing the guard cells to close. This point have to be noted down for stomatal closure. They cause partial or complete closure of stomata. Complete closure of stomata adversely affect gas exchange and photosynthesis. This point you have to note down. When you are using this type of chemicals, they will completely close the stomata, which affects gas exchange and photosynthesis. So it will affect the plant growth also. In order to, if you are concentrating to reduce the water or transpired from the plants, if you are spraying this anti-transparent, it also affect gas exchange and photosynthesis. So these chemicals may also cause phytotoxicity and they are expensive. It is not a required question. You have to concentrate on, if we are using they will ask this applied type of question. If we are using stomatal closure of anti-transparent in plant crop, option A, it will be helpful for photosynthesis. Option B, it will affect photosynthesis. Option C, both A and B. Option D, none of the above. Here it will clearly affect the photosynthesis by the process of gas exchange. So these are the examples you have to remember. Along with that examples, you have to identify this point. It is different from all the three types, so you should not become complex with these questions. Okay. Now The second type is that is reflectant type. Reflectant type of anti-transparent, here you examples are kaolin, lime solution, here you know that. But it increases the leaf albedo or leaf reflectance, and as a result heating is reduced, leaf temperature inside is low, and need for transpiration is reduced. Here what it is, less expensive, non-phytotoxic, and don't interfere with photosynthesis. At this point you have to note down. Please see here the difference between the stomatal closure type and reflectant type. Here they will not interfere with the photosynthesis process. This reflectant type of anti-transparents will never interfere with this photosynthesis. But when comes to the stomatal closure type of anti-transparents, they will adversely affect. So chances of question is that the type of anti-transparent which affect the photosynthesis is option A reflectant, option B film forming, or option C growth retardant. They in next class I will explain how it will affect and how it will close the stomata. So the as a question type is like this: the type of anti-transparent which affect photosynthesis. Option A stomatal closure, option B reflectant type, option C both A and B, option D none of this. Here you have to go for only stomatal closure. Okay, the reflectant type will never affect the photosynthesis. Then another question, another type of anti-transparent is film forming type. It will also cover the stomata by forming a thin film. These substances are non-toxic, non-degradable, and very easy to apply. Adversely affect the photosynthesis. This film forming type will also adversely affect the photosynthesis, that is paraffin and wax emulsions. Here you mark this point, that is wax emulsions. Wax emulsions, please note down this question or that word, because in so many SRF exams they are giving this not only in agronomy paper, in soil science paper also they have given, in also in breeding paper also they have given this question, that is wax emulsions, whether they will affect or not. Film forming type and stomatal closure type, they will affect photosynthesis. Reflectant type, they will not affect the photosynthesis. When comes to the growth retardant type, chemicals like psychosil, when sprayed on the foliage, reduces the leaf area and thereby reduces the transpiring area and transpiration. Here, what they will do, all these cases, the above three cases, what they will do, they are having mechanism with the stomata. But here, this growth retardant type, it will reduce the leaf area. By in turn, it will reduces the photosynthesis. That means here they will reduce the transpiring area. So there is no, sorry, here growth retardant type will not affect on photosynthesis. They will only reduces the leaf area, thereby reduces the transpiring area. So which are the chemicals, anti-transpirants, which affect the photosynthesis are two. That is, first one is stomatal closure type and another one is film forming type. Okay. What are the benefits of anti-transparency? It is a very known points where you can observe in almost all the textbooks, that is optimize yield levels under infrequent rainfall situations, saving crops with marginal crop productivity, that you can observe in almost all the crops. And then mulching, different types of mulching are there. When comes to the mulching, two important topics are there. What you can observe here is when comes to the mulching, that means two types of mulchings are there. One is degradable mulching and non-degradable mulching. That means whether you are using the plant residues, and that types of mulching are there, and whether using plastic, that type of mulchings are also there. Two types, not two types, very important mulching here is vertical mulching and dust mulching, where we will practice this vertical mulching. That is in case of which soils. When it comes to the mulching, vertical mulching is very important point where we can done the practice in case of black soils, vertical mulching, and dust mulching, that is repeated cultivation in order to cut down this capillary water movement. We will do this dust mulching, that is repeated cultivation. Here you can see the dust mulching or soil mulching. Repeated intercultivation results in the formation of soil mulch on the surface referred as soil bar dust mulching. This is the one very important point. where in some textbooks the soil mulching is given, you may be confused with the this soil mulching and normal mulching, because students are remembering that mulching means any crop residues if you put on the soil surface, it is nothing but mulching. Yes, definitely that is also a mulching. And the soil bar dust mulching means whenever there is lesser water, when there is no rains, even though transpiration occurs. So in order to reduce that capillary movement, in order to reduce the pore spaces, in order to cut down that pore spaces, we will do repeated cultivation. That is nothing but dust mulching or soil mulching. Please note down this question also. Soil mulching or dust mulching. Vertical mulching I will explain with the diagram in the future classes. So here you have to understand that repeated intercultivation results in the formation of soil mulch, that is called as soil bar dust mulching. Okay. Transpiration and crop productivity, which are the different factors: light, temperature, soil, water, wind, humidity. Here it is not at all required for you because it is not at all. They will not ask any questions. So now the next concept is water deficit and its effect on plant growth. I think this will be taken in the next class. Water deficit and its effect on plant growth. I will not come for this completely because I need some your response also regarding these topics. So now it is open for discussion. You can ask any doubts regarding these topics. So I think all are listening, so you can ask any doubts, because based on these topics, the next week we will discuss some problems. Some transpiration related problems are there. That means how much of water is transpired by the different crops, or what is the amount required for the transpiration, what is the energy required for the transpiration. This type of single marks question you can expect also. That type of problems will be discussed in the next class. So now it's open for discussion. Please ask anything you are having some doubts. Okay.
Excuse me, sir.
Yes, yes.
So please, can you give us this word file?
Okay, okay. I will share. I will share. I will share.
Okay, sir. Okay, thank you.
Hmm.
सर हेलो
Vishu, right? Yes.
सर वाटर अल्टीमेट वाटर पोटेंशियल क्या होता है सर
Ah,
अल्टीमेट
ultimate.
वाटर पोटेंशियल जो
Ultimate irrigation potential means we are having 400 million hectare meter of water every year. We are getting, that is 400 million hectare meter of water is our present water scenario in India. Among that, what is the amount of water where we can using for irrigation purpose? Ultimate no, potential. What is the, they may loss to the transpiration, or they may went for the seas or basins. So what is the amount of water? How much we are utilizing is 140 yeah, that unit 140 hectare.
ओके सर
Okay, okay. So previous week some problems are discussed. Any doubts on that problems we will discuss here. And regarding problem solving, next week we will solve some different problems regarding to this topics, transpiration and some other topics. So I think I am much speed. Sorry, I don't know whether I have to cut down my speed or not. Whether you have understood this topic or not, please let me know. Because some persons are texting me, sir, class is very speed. Is it so?
No, sir, it's okay.
It's okay. Right, right. Okay. Any doubts regarding to this class, guys?
नो सर
Okay. Thank you. Thank you. Right. We will meet you soon. That means in next week, we will discuss with some problems regarding this anti-transparents concentration and also some transpiration related problems. Okay.
Okay, sir. Thank you, sir.
Right, right. Bye.
Bye. Hello, sir.
Hello.
Hello, sir.
Tell me, Vardhan.
Sir, can you share this YouTube link, sir, in WhatsApp group?
Okay. I will share. Okay.
Thank you, sir.